Good day. With respect to fundamentals of big data, module one. So let's talk about just Hadoop ecosystem. In the previous topic, we did discuss about the different tools of big data that we did talk about noise to databases, which we did to discuss about of the tools, how exactly the represent, how we visualize, starting from administration to the visualization. How exactly those tools are modified to give. Now we will move on to the next topic, which is about the ecosystem. We'll try to understand more about what are the different components of the how exactly they represent our managing the let us begin with the topic. So it is well understood that Hadoop is not a single product. It's an ecosystem of projects and tools built around core HDFS and YA. So in the previous topics, you have got an idea about what is HDFS, that is Hadoop Distributed File System, and YA means yet another resource negotiator. So we need to understand the analogy here. With Hadoop code, there is combination of HDFS and YAR with the operating system, like Windows or Mac operating system. These ecosystem tools are the applications such as Word, Excel, or Chrome. So each tool is designed to solve a specific problem within the big data lifecycle. So Hadoop is a data management system bringing together massive amounts of structured and unstructured data that touch nearly every layer of the traditional enterprise data stack, positioned to occupy a central place within a data center. We hope you are aware about what is a data center, how exactly that is utilized. So here we need to understand that Hadoop is a data management system wherein there is huge amounts of unstructured and structured data which touch bases every layer of the traditional enterprise data stack positioned to occupy a central place within a data center. So Hadoop is a massively parallel execution framework bringing the power of supercomputing to the masses, positioned to field execution of enterprise applications. Hadoop view as an open source community creating tools and software for evolving data problems. Hadoop provides such a wide array of capabilities that can be adapted to solve many problems. Many consider it to be a basic framework. Hadoop provides all of these capabilities, but Hadoop should be classified as an ecosystem comprised of many components that range from data storage to data integration to data processing to specialized tools for data analysis. So Hadoop serves that ability wherein this ecosystem has anything starting from data storage towards integration, processing, any tools that we refer to for the data analyst. So this is the Hadoop ecosystem. So let us see the key players in this ecosystem. So I know whenever we talk about the big data analytics, we need to understand it all starts with the data ingestion, data processing, data warehousing, the whole workflow. So what tools assist in which specific aspect? Let us begin with the data ingestion. So you can see Scoop, which helps out in moving bulk data between Hadoop and structured databases. This is structured databases referring to MySQL. Flume is a tool which is for collecting, aggregating, moving, streaming data like log files or social media feeds. That is with respect to the data ingestion. So what about the data processing? MapReduce batch processing is being done with them. Then the batch Spark, which we know that it's fast in-memory general purpose engine, so the modern standard. And Apache Flink, so it's a true real-time stream processing. So that is with respect to the data processing. What about the SQL on Hadoop? So Apache Hive, which is an open source providing an SQL-like interface, query the data in the Hadoop distributed file system. The standard for the batch SQL ETL. Apache Impala, high performance, low latency SQL engine for interactive analytics. Then we have NoSQL database. So here we have Apache HBase, a non-relational column-oriented database for fast, random read or write access to huge data sets. So the workflow and orchestration is where we are talking about batch QC, a scheduler for managing and coordinating complex Hadoop jobs. So you can see starting from the HDFS, the distributed reliable storage, the programming model, MapReduce, NoSQL database, HBase, Scoop, big, high, easy, Zuki. So all of these are the Hadoop ecosystems components. So let us take what really happens in the day, in a day of the life of data. It is, let us take ingest, where Scoop imports daily transaction data from retail database, then Flume streams in web server, Clipstream logs in real time, and the data lands in HDFS. So after the ingest, it moves toward the store process. All raw data is stored reliably and cheaply in HDFS. So after the storage, we move on to the process and transformation. So Spark or Hive job runs overnight to clean, transform, and aggregate the raw data into a structured component. So after the process and transformation, we analyze and serve. So business analysts use business intelligence tools like Tableau to run interactive queries on the cleaned data using Impala or Spark S2. A real-time dashboard queries HBase to show up the second website activity. Data scientists use Spark MLIB to build a recommendation. So this is what happens when we try to work with the data with all these tools or this specific ecosystem. So beginning with the zookeeper, so let us see all the tools one by one. How exactly are they working in this ecosystem? So first, let us see the zookeeper, which is the Hadoop's distributed coordination service. Zookeeper is designed to run over a cluster of machines. So it is a highly available service used for the management of Hadoop operations and many components of Hadoop development. So it is the coordination service. So it goes over the cluster of machines, highly available service so that you are able to manage the Hadoop operations. Most of the Hadoop depends on such coordination service. So next is Uzi, the scalable workflow system. It's integrated into the Hadoop stack and is used to coordinate execution of multiple MapReduce jobs. And also, Uzi is capable of managing a significant amount of complexity, basic execution on external events that include timing and presence of required data. Uzi is capable of managing a significant amount of complexity, basing execution on external events that include timing and presence of required data. So the next component is Fig, an abstraction over the complexity of MapReduce programming. Execution environment and scripting language Fig Latin is used in the datasets. Its compiler translates Fig Latin into sequences of MapReduce programs. So before we get further, let us try to understand some of the components like scoop and fuel. You need to know that Hadoop was created to solve the big data problem. So volume, velocity, variety. Its core is HDFS for distributed storage and YARN for resource management. A rich ecosystem of tools like these Hive, Spark, Scoop, etc. Provide specialized functions for ingestion, processing, and analysis. Patch Spark has become the dominant engine for fast in-memory data processing. The principles of Hadoop are fundamental, but its implementation is shifting towards cloud-native services that unbundle storage and compute. So, Scoop is a connectivity tool for moving data between relational databases and data warehouses and Hadoop. So moving data between relational databases and data warehouses and Scoop leverages database to describe the schema for the imported or exported data and MapReduce for parallelization and fault tolerance. So Flume is a distributed, reliable, and highly available service for efficiently collecting, aggregating, and moving large amounts of data from individual machines to HDFS. It is the Hadoop distributed file system. It is based on a simple and flexible architecture and provides a streaming of data flows. It leverages a simple, extensible data model, allowing you to move data from multiple machines within an enterprise into another. So, on the whole, Chrome is a distributed, reliable, and highly available service for gathering, aggregating, and moving humongous amounts of data from individual machines to a distributed file system. So, with that understanding about the different components of Hadoop ecosystem, let's try to solve these MCQs. So, we'll take like 3 minutes of time and you can try to solve these two questions and your time starts. Okay, so it's almost time, another 10 seconds. Okay, so let us discuss the answers now. The first question, which component of the Hadoop ecosystem is responsible for coordinating and managing the resources in a Hadoop cluster? So the first option is Yarn, which is yet another resource negotiator. The second option is HDFS, Hadoop Distributed File System. The third option is MapReduce, and the fourth option is the patch pick. So we're talking about responsible for coordinating and managing the resources in a Hadoop cluster. So the right answer will be Yarn, which is yet another resource negotiator. That's the right answer. It cannot be HDFS or MapReduce. Yeah. So the second question, which is which of the following is not a core component of Hadoop? First option is HDFS, Hadoop Distributed File System. Second option is MapReduce. The third option is YARN, yet another resource negotiator. The fourth option is Spark. They are asking which is not a core component of Hadoop. So the right answer will be Spark because HDFS, MapReduce, YARN are core components of Hadoop. So you have got an idea, and I hope you were able to solve these two questions. We had really listened to the video from the first to all these topics. Now, I thought to include some descriptive questions as well so that you will have an idea on how to answer such questions. I also given a small part of key points when such questions are being raised. So the descriptive question is explain how the components of the Hadoop ecosystem, such as HDFS, YARN, MapReduce, Hive, and HBase, work together to manage and process large-scale data. How do these components complement each other to provide a cohesive data processing platform? So you have to explain how the components of the ecosystem, is the Hadoop ecosystem, work together to manage and process large-scale data. And how do these components complement each other to provide a cohesive data processing platform? When we say components of the Hadoop ecosystem, they have already given HDFS, YARN, MapReduce, Hive, and HBase. So you have to detail about what is the Hadoop ecosystem, that is the collection of tools and technologies that work together to store, manage, and process the large-scale data in the distributed computing environment. And the main components of the Hadoop ecosystem, the Hadoop distributed file system, yet another resource negotiator, MapReduce, Hive, and HBase, how all these components work together to provide a cohesive data processing platform. We need to explain all these components one by one. That is, Hadoop distributed file system, yet another resource negotiator, MapReduce, Hive, and HBase one by one. Next question is using a neat sketch, depict the layer, the tools, and utilities within that layer. So this is with respect to the Hadoop ecosystem. So there is the possibility of having a question where they may ask you to develop a neat sketch, depict the layer of tools and utilities within that layer in the Hadoop ecosystem. So you can see the sketch needs to have the process starting from the data ingestion, and then it's about the processing and transformation, how exactly delivers it. So starting with the scoop, storm, the Hadoop core, the distributed file system, MapReduce framework, YARN, the NoSQL database, the machine learning, distributed program, that is the talking about Apache Fig, and Hive, Apache Spark, and the scheduling, the Woozy, workflow, the system deployment, and the service profile. So we want to talk about this picture should have almost everything, and the connectivity needs to be there as well. So you cannot just like that create some blocks, leave it just like that. They need to have that connectivity amongst them, wherein it starts with the data ingestion, how the data ingestion is connected with the distributed file system, And the MapReduce framework is yet another resource negotiator. The NoSQL database, the patch, pitch base, and also the scheduling, using workflow, the distributed programming, like big scripting, um, then the high SQL to the patch Spark, and machine learning as well. So all these together, how exactly are they really forming this Hadoop ecosystem? How do they process this data in a proper manner? So that sketch needs to provide that detailing by naming all of those components and how exactly do they really is done. So with that, we come to the end of this particular topic about the Hadoop ecosystem. So for reference or additional detailing, you can go through this particular book, Big Data and Analytics, published by Wiley Publication back in 2020. We did see about what are all the different components of the Hadoop ecosystem, and how exactly they complement each other, and what exactly happens for a data in the Hadoop ecosystem, starting with the ingestion, processing, the workflow, the coordination, all of that needs to be taken into consideration. We talk about the Hadoop ecosystem. And we did also try and have an idea about the possible descriptive questions that may be asked. We need to make sure that we're listing out the detailed information of the ecosystem, how exactly different components work in the whole ecosystem, Hive, HDFS, Hadoop distributed file system, Lucy, and the workflow, Zookeeper. um, So that will close this particular session. So hope you got an idea about what is the Hadoop ecosystem, different components of this Hadoop ecosystem. So thank you very much for your patience and carrying out this video. We will see about these components in the Hadoop ecosystem in detail in following sessions. Thank you.